Long time no see, apparently. So just usual slide. I'm not building anymore the same stuff that I used to. The slide is different than the previous one. I'm actually now working on containers here in Pure Storage. That's the only difference. Uh, Also, I'm not sure if this whole series makes sense given all the AI stuff, but hey, uh, maybe it'll help you to work with that. I don't know. So maybe just a first recap what we covered last time. We talked about some core principles, why the style is important, uh, and the hardest thing, the naming stuff. So the core principles were simplicity over cleverness, readability counts, convention over configuration, right? I'm reading those again just to make sure that everyone follows and understands. We are going to continue the convention over configuration. Right, last time we discussed naming and also the tooling. We haven't actually talked about the projects, how they look, right? So that's exactly what we want to cover, what I want to cover in this episode. Some bonus also, there's one more topic. So first, directories, organizing packages, how to actually evolve projects, right? Like there's a lot of different opinions on that, but I think that we as a community, Go community, arrived at certain things. So let's go to it. So you should actually start really small, to be honest. Like this is how most of my projects started like this. I have just one file and you feed it in as long as you can, right? It's actually useful for if you're exploring, also if you're creating simple CLIs and so on. Going to the AI topic, I usually start with telling the agent just go one file, then go overblown. Otherwise, I get lost, right? I can't follow. So the next level, that's where very often I finish, is I just put more files just to organize it a bit, but it's still one package. Like don't overcomplicate, right? The tests are there, everything is in place, looks good. If it's like 15 files, you can probably still handle it easy, right? My go, my, I really don't like over engineering, so like go with the smallest possible solution. So I think that really works. Even in like most of the CLI tools that I ever wrote fit in this. But then obviously not everything is like this. There's this sort of like enterprise grade stuff. You make plenty of directories with different meanings and you hide all the complexity somewhere, right? For some, it may feel that this is random, like just like how I feel about it, but actually, this is sort of how most of the projects look these days, or should look. If you doesn't, maybe think about this one. How to actually evolve it. So there is a bunch of stuff, right? Like the CMD, that's very popular. That's for the entry points. Internal, actually internal is interesting. PKG, like packages, right? API config scripts, a lot of stuff. Let's go one by one, right? This is actually like for most of the like server backend stuff. Like if you look at the open source things like Kubernetes, Docker, they all kind of like follow this. So, okay. What the hell is this? Okay, cool. So CMD, that's the first one. That's kind of like the entry point. That should usually be very straightforward and simple. And there should be just one file in the subdirectory if you have more than one. And that should be called actually main Go. And that's the entry point for all your binaries you produce. And as you can see on the right side from your perspective, it should be very simple. It should actually basically call other packages and just a tiny wrapper. So you get the main function and you can build stuff. Nothing else. Everything else goes to internal or some other bits. Okay, the internal, that's the actually, that should be the meat of your project, so to speak. This one, since Go 1.4 is actually treated specially, and you cannot reference as any package from other projects, right? You cannot include it in different projects. So this is where most of your stuff should go. It's kind of like your internal library, so to speak. So you package internally. How to actually create packages, we'll get to that, right? Then there is this usually called PKG package. That's where you put like packages you are fine with others to use because they can reference it. The history behind this is that actually when Go started, the standard library was shipped as under like PKG. So that's why PKG. The whole standard library was PKG. So that's why now a lot of projects copied that. And these days is the place where you put the reusable stuff that you want to share. So again, if you look at a lot of the open source stuff, you'll see they have it, and they have here loose useful things, and you can reference them directly in your projects too. But there is a caveat. If you put it there, someone may rely on it, and then they will blame you if things don't work. So think twice. I usually start like, no. Internal is fine. Don't show anything, right? Okay, then that should be kind of like it for most of the Go code. And then you have like plenty of things that are, again, sort of rules or conventions on where to put the no Go code stuff, right? API, very popular. That's where all the definitions for your API should land, right? Like Swagger or OP and API spec, to be precise, protobuf, anything like that. Nice example, Kubernetes. Configs, that's either your real configs or templates or whatever is useful to guide you, like maybe examples and so on. Again, a lot of projects have it. Scripts, I'm pulling in Helm to show what they have. Again, this is usually used for like all the operational stuff, like whatever scripts you have for whatever things you do, right? Building, installing, analyzing stuff, and so on. Build, that's another one that's very common. And it actually has even conventions on what you do, like build packages is where you put like your Docker files or Debian packages if you build them and so on. Kind of like packaging things. And I think CI ideally goes into build CI, but hey, if you're using like GitHub Actions, you do .github whatever is the subrepository, right? Like, it'd be nice if they could use that, right? But in general, build CI is a convention. But projects are actually growing more and more, right? Like this is still not enough for a lot of things. So for example, if you're doing anything with assets like images and so on, the convention is put in assets. Docs, if you're not writing docs, you're doing it wrong because your AI will not be able to help you. So I think the docs is really important. It's maybe the most important part of the project now. Obviously test for anything that's not like unit tests should land in tests. Vendor, that's another one that you see often. That's the old school way how to do packages, how to actually use third parties. You basically vendor the code. So Go mod vendor creates this folder, put stuff in there. VAP, that's when you have like front end, for example, you're using Angular or whatever. That's where you put stuff. That's sort of usual place. Actually, this all is actually described in this standards layout. GoLang standards project layout. There's plenty of details, links to other bits worth exploring. All right. This whole talk, I basically just went there and just like copied everything, more or less. Right. Cool. So now the packaging, right? Like how to create packages. There's two ways of doing things. Like one is thinking about like how it actually sort of captures some features on encapsulates, and you kind of like do microservices on package level, or how to call it. Or you group things by what they do, right? Like if you have models, you put all the models in some one place and so on. That latter one is kind of like against what Go does in general, right? The idea is that each package should be somehow like encapsulating all the stuff that's important. So it should be like one unit. And also the point is to reduce coupling, right? Like, so you want to actually encapsulate, hide it. Everything complex is in the package. The simple API to consume. So the bad one, you do it by actually like technical layers, so to speak. So you use like models, services, reports. You can like build the abstraction this way. That's not encouraged in Go, although I've seen plenty of places where it's been used. The right thing is you think about the feature or a domain and encapsulate that and hide that, right? So you have like, oh, some representation of a user, that's a package, so on, right? That's the ideal world, how to do it. If you're working on legacy code and you cannot change it, you cannot change it. So to avoid past mistakes, right? There's some like common stuff. Don't go overcomplicate it. Start with simple things like it's better than going with full blown like CMD, all this stuff, and you have just one main Go and that's it, right? Doesn't make sense. Creating anything like utils, helpers, come on, and all this sounds like cool, but it usually means like these packages are everywhere and they are like, they feel like viruses, they spread everywhere. Then you pull everything, and it's kind of like, you don't know what is inside. Whoever felt this was nice to have common and is used in one place only and so on. Try to avoid that as much as you can. Making everything public in PKG is also bad because you discover people using it. You never know like who's searching for the source code to actually avoid doing the work. So circular dependencies in packages, that's a very subtle one, but it can actually can bring a lot of complexity later. Once you start refactoring, you realize, oh, this is like a big rewrite. Sorry, it's the zoom. And also like copying all these structures, like you go this standard project and you copied everything and you don't know why, right? Just don't do it. If you don't know why you're doing it, don't do it. Just in general, I think. Like I told this my kids. If you don't know why you're doing it, don't do it. And also like evolve it slowly just so you get control, right? Start flat, introduce internal if you need packages. Actually, I would argue that the CMD is useful only if you have more binaries than just one. Right? If you're producing just like one binary out of it, like main Go and the root is fine. Maybe some people disagree in this audience, but that's just my take. Right, so that was nice. And now, like, I think one of the really important bits that Go has is how it handles errors. It's different than the most modern languages out there. So I thought that would be nice to actually cover this too. Right, the project was cool, but we can, this is actually more important, I think. That's why it's later. Now everyone is watching. So errors are values, right? That's a really important one. Like the error handling is very explicit. It's in your face. It's the if error language. That's how I see it, right? The point is that you should be checking them immediately. You should actually handle it somehow, right? Like do something with it. Don't hide it, right? It is just another return value. So you can treat it as a return value. It depends what you want to do with it. You can, right? This actually is an example from the previous talk, which actually said like, oh, it's good to actually go and handle it immediately. Otherwise, you get to the hell. That's the second one where you're saying like, oh, if this error and maybe this one or maybe not this one, whatever, get complexity. Just don't do it, right? That's the first thing. Errors are values, right? So error handling in 4 points. There are no exceptions, no try-catch blocks, nothing hidden. There's a caveat to it. We'll get to it, maybe. But the point is, you handle it when you see it, not later, and you don't hide it in an exception that get like bubbles up somewhere, right? Errors are values. It's not exceptional. Like most of the programs, like when you write a program, you know what things could go wrong, and you kind of like figure out like what to do with it. It's totally fine to crash, right? Also, it's just conscious decision. Sorry. Explicit is better than implicit, right? Again, if error, I know it's really boring to write it, but you should have a good editor that actually does it. And if you're using AI, it actually writes all this code for you. So there's no reason. And actually, like what I like, it forces you to think about it. Like the stuff is returning something. I need to do something about it, right? So that's the essence. So for the beginners, you always check errors. Like just don't skip it, right? Like you could actually say like put the underscore and ignore it. I think there are exceptional cases where you could do it, but you shouldn't. In general, you shouldn't, right? Better is handling it somehow. Exiting program is totally fine, right? You should be using, you should be wrapping the errors. That's another very useful thing. It was introduced in Go 13, I think 1.13. Now you can actually nest errors in themselves, right? So that's the W important. When you format error F and you use W as %W, actually you create sort of like a tree of errors possibly, right? And you can wrap many. It's useful because then later you can check for specifics, right? The other thing, you also gonna like get nice messages nested and so on. So wrapping, really important. Now it gets like the checking the errors. Like if you want to go clever and see like, oh, I'm handling not just like, oh, whatever error happened, I do something, but I want to be specifically handle some of them, you use error.is. Here, it's very useful when you're using wrapping because you can, for example, use the SQL error no rows and you can check for it, even though the error itself on the top level was something is like user not found, right? For example. So you can actually check for the type and it will find one if that matches in the whole chain. So if you wrap 5 and like the first one was SQL no error, SQL no rows, you'll get to see it and you'll be able to match it. If you do SQL equals, if it's wrapped, you will not see it because it checks only the top one, right? The other thing is the as, which allows you to actually do something if the error is this is of that type. And that's when there are specific fields you want to handle differently, or it's a specific case and you want to actually show, maybe make a decision based on some internal field of the error, right? So this is, I think, an example that I try to come up with an example that actually captures the essence of it. All right, so I have a customer, very useful thing if you want to pass around more than just messages, the string. I actually forgot. I realized like that error is basically just anything that actually any type that has the error function implements the interface, right? So it can be like arbitrary struct, can have whatever. If there's an error function to it or method to it, you'll be fine. It's an error. There's a custom to call it actually end with error as in the name of the struct, so it's obvious. But putting that aside, you can have custom errors, and it's extremely simple to use, as you can see in the code. And if you actually wrap it here, it's shown, right? Or here is it shown? Oh, it's actually not shown. It didn't fit. Oh, I see. It didn't fit. Sorry, I had it in mind and I had to edit this slide so it fits. But anyway, there is the error as which actually is exactly the use case for showing you like, hey, I want to actually structure this output differently. So I handle it. Like if I get something else, I'll just dump it, right? Cool. If this was not wrapped and it was below somewhere hidden, it would actually not work, right? Cool. So now the question is like when to wrap and when not to wrap, because sometimes it's useful, sometimes it's not. One thing is you should not return wrapped errors from your packages, because packages, that's the API boundary. That's like, oh, this works like this. So you should actually return do not nested, because then you're kind of like leaking your internals, and maybe someone will later rely on it and you change it and all of a sudden it doesn't work and it breaks unintentionally. So that's really important. Like packages that goes to internal or the public ones, none of them should do it, right? That's because just because it's internal doesn't mean you can do whatever, right? You should not. That's one. When there are situations, and I think the sentinel errors, as in like, oh, this is the thing that you want people to be able to match. I think it goes to API boundaries. Actually, most of the time, that's where you want that feature. Or don't nest if it's like obvious, then you don't have to nest. So on. Like the context is not useful. Like you're not bringing any value, right? So this is actually intentional. You may feel like it's an empty slide. Yes, because I deferred something. Right, that's a really important bit to cover in the error handling, and it's defer the cleanup. Like when talking errors, most of the time you want to actually, if you're actually having any resources, you want to defer some stuff, right? Defer is actually very generic. It's not only for error handling. It's a very obvious case, but it's not only for that. It actually is a way how you schedule something, a function that will always run after the function where you wrote it, where you deferred, finishes. And it doesn't matter how it finished. As in, it could error, it could be fine, it could be happy path, it could even panic, right? Like, so in all cases, it always run. It has, it's very useful, right? So the first example shows the behavior, right? Like I'm deferring that, it will be the last function to call. It will actually in the output show the last time. If you defer and you stack them, they are actually stacked, right? So the last one goes first out. If you defer and there is a variable and you reference it directly, right? It actually evaluates at that point, and that's the capture value. If you wrap it in a closure, it will get evaluated actually as a reference in the very end, right? So what this implies is, for example, if you're deferring in the loop, you will most likely just stack them, then it will all unwind, right? So that's maybe better to actually wrap it, and so it goes like every single loop finishes. You don't defer, you close, right? Or you capture all the outputs and so on. Otherwise, it may actually end up like a long chain of differs, right? So what are the use cases, right? Like why deferring? Like I actually, one of the is resource cleanup. That's the read file example, right? If you're processing the file, like the close will always make sure that that file is closed, right? It goes for sockets. It goes for basically any resources that you open, right? It could be pipes or whatever. This is the example. Another one is when you're using mutex to actually use it, like deferring the unlock is really important. That's the best way how to avoid deadlocks, and it's the simplest way how to actually use logs. A neat thing that I used many times was using it to actually time stuff. Right at the very beginning, you defer the function call, and you actually start something, and then you defer, like the example is exact, right? Like I'm actually returning a function. That function gets deferred, so you capture the start, and then at the very end, after everything is finished, this function will be called, and you'll see like timing, right? It could be also used for other scenarios like this. Let's see, a useful one. Other thing that's common is database transactions, right? You actually defer the transaction. So you always make sure that it goes in. You don't forget. Cool. Now, now the error handling for beginners, like what is the stuff you need to know? You use W for wrapping, single V for if you don't need to chain. Wrapping really important. You add in, when you're wrapping, add stuff, add useful information in it. Otherwise, like why wrap, right? This is a useful one. Actually, the stuff is chained and looks better when everything is lowercase. If you put uppercase, it gets messy. Do like if you most of the time it's better to use error is or s, like to capture to match rather than like specific values. The custom errors are useful when you want to add like very specific features, and you want the caller to actually have a way how to handle it properly, right? If there's a meaningful way for that. Otherwise, don't bother, and don't forget to defer the cleanup, right? So that I was talking about this like try catch, right? Panic that is there, but I actually am deferring that one to next episode, right? So it's a nice topic, but it's on own, and it would take another 5-10 minutes, and I don't think that we have that, right? So thanks a lot.